Hi everybody! So today we're going to be starting to talk about greatest common factors, and we're going to be looking for numbers that go into other terms or variables that go into other terms. So let's start by reviewing what a greatest common factor is. Now you may have learned about greatest common factors before. So greatest common factors are variables or numbers that two different terms, I guess it could be two or more, are divisible by. So if I say, what would the greatest common factor for an 8 and a 6 be? You would ask yourself, well, what number goes into 8 and 6? So the numbers that go into 8 are 1, 2, 4, and 8. And the numbers that go into 6 are 1, 2, 3, and 6. So if I try to look for what numbers go into both, that are divisible by both, the 1 goes into both, and the 2 goes into both, but those are the only two numbers that go into both. So we want to choose the bigger of the two numbers. Since the 2 is bigger, it is going to be the greatest common factor. So our answer here to this problem would just be 2. Now if I gave you, instead of just an 8 and a 6, an 8x and a 6x, well, we're dealing with the same numbers. So we know that the biggest number that goes into an 8 and a 6 would be a 2. But then we need to think about the x's. Both of these terms have one x. So they have that in common. Common means, what do you both have? Well, we both have one x. So x would be part of my common factor. So instead of just the common factor of 2, this time the common factor would be 2x. Now what if we changed this to 8x squared and 6x? Well, we're still dealing with an 8 and a 6, so the number that goes into both of those would be 2. But now this time, this guy has 2 x's and this guy only has 1. Now we want to be in common. That means we want to be the same. Well, we only have in common that we both have 1 x. We can't say we both have 2 x's because this guy doesn't, but we both have at least 1. So we would put x here as part of our common factor. Now what if one of your terms had an x and the other one didn't? Again, we're dealing with an 8 and a 6, so the number that goes into both would be 2. However, this time if I say how many x's do we both have, at least that many x's, we would say, well, this guy doesn't have any x's and this guy does. So we don't have that in common. I can't take out an x. I can't say we both have an x because he doesn't have any. So our common factor would just be 2. Last but not least, if we had 8xy squared and 8x squared y. Well, the number that they both have in common is 8. These are both going to be divisible by 8. Then if we look at the x's, this guy has 1x and this guy has 2 x's. So the biggest amount we have in common that we both have is just 1x. And if we look at the y's, this guy has 2 y's and this guy has 1 y. So the biggest amount we have in common that we both have is just 1 y. Now, what we're going to be doing with this information is something called factoring out the greatest common factor. So what we're going to be doing is taking a problem where we used to be distributing and then undoing that. So let me show you an example. We remember how to distribute in this problem. I would distribute the 3x to the x and to the 4. So I would have 3x squared plus 12x as my final answer. Now in the problems we're going to be doing right now, we're going to be trying to undo that. So I'm going to give you 3x squared plus 12x, and your job is to undistribute that 3x. So how are you going to know to do that? Well, as you can see here, there are two different terms in my problem. We need to now figure out the common factor for those two terms. If I look at the numbers, the 3 and the 12 are both divisible by 3. And if I look at the variables, this guy has 2 x's and this guy has 1. So the common amount would be x. That's what they both have. We can't say the common amount would be x squared because he only has 1x. So we can only factor out 1x. Then we're going to write a parentheses, and then we're going to divide. So when we distribute, our operation is that we are multiplying. But when we factor, our operation is that we are dividing because we're going backwards. So 3, we're going to do one term at a time. 3 divided by 3 would be 1. X squared divided by x would just be x. We're taking out one of the x's. So since he had 2, there's 1 left over. Then 12 divided by 3 would be 4. X divided by x would just be 1. They would cancel. They would go away. So I don't write any x's here. He used to have 1x this term, and I took it out, so now I don't have any x's left. And this would be your final answer. Now, if you look at this answer, 3x parentheses 1x plus 4, you're going to notice it looks like the problem we started with here. We're just going backwards. We're undoing distributing. So let's practice this a couple times. For problem number 1, it says factor out the greatest common factor. So my first question is, what number goes into both 3 and 6? And the answer would be 3. Then I'm going to put a parentheses and I'm going to divide because I want to make sure that I am undoing multiplication. So when I divide, 3x, we're going to do one term at a time, divided by 3 would just be x, and 6 divided by 3 would be 2. For problem number 2, if I say what do these terms have in common, what is the common factor? Well, they're both divisible by 3 because 3 goes into 3 and 6. And this time they both have an x. Now this guy has 2 x's and this guy only has 1 x. So I can only take out 1 x. That's the most amount that they both have. However, there's one little trick here. Whenever there's a negative in front of your first number, you're going to divide by that negative. You're going to take it out when you do your division problem. You always want your first term to be positive. So now I'm going to put a parentheses and I'm going to divide. So negative 3x squared divided by negative 3x. Well, negative 3 divided by negative 3 would be 1. X squared, take out one of the x's, I would only have one of the x's left. Then I'm going to look at the 6x. Now positive 6 divided by negative 3 would be negative 2. One of the x's, take out one of the x's, there would be no x's left. So that would be my final answer, negative 3x parentheses 1x minus 2. For problem number 3, now in problem number 3 we actually have 3 different terms. So when we look for a common factor, it needs to be a number that goes into all 3 of these numbers. So what number goes into 3 and 6 and 9? Well, the biggest number that goes into 3 and 6 and 9 would just be 3. Now let's look at the x's. The first term here has an x cubed, the second term has an x, and the third term does not have an x. So if I say what do they have in common, well, the last term doesn't have an x. So the answer would be just the 3. We can't take out any x's because they don't all have an x. Parentheses. Now we're going to divide, so one term at a time. The first term divided by 3 would just be x cubed. The second term divided by 3 would be 2x. And the third term divided by 3 would be positive 3. Remember, we're dividing. We're undoing multiplying. For problem number 4, what do they have in common? Well, what number goes into 7 and 14? They're both divisible by 7. And just like before, if our first number is a negative, we're going to put a negative here. Now we're going to look at the x's. So this first guy has 3 copies of x, and the second term has 2 copies of x. So I can actually take out 2 copies of x. They both have at least 2. So what's left? Well, negative 7 divided by negative 7 would just be 1. 3 copies of x, take out 2 of them, we have 1 copy of x left. Then negative 14 divided by negative 7 would be positive 2. He used to have 2 copies of x, but we took them both out, so there are no x's left. Next, what number goes into 2 and 4? Well, the answer would be 2. Now we're going to look at the x's. This guy has 2 copies of x, and this guy only has 1. So the biggest amount we can remove is just 1. This guy has 3 copies of y, and this guy has 2 copies of y. So the biggest amount we can remove would be 2 copies of y. Then we need to ask ourselves what happens when we divide. So 2 divided by 2 would just be 1. He used to have 2 copies of x, but we took one out, so now he only has 1 copy of x left. And he used to have 3 copies of y, but now he took out 2, so he only has 1 left. 4 divided by 2 would be 2. 1 copy of x, take away 1 copy of x. When you divide, it cancels, it goes away. He used to have 2 copies of y, but now he doesn't have any copies of y left. We took out 2 copies. So this would be your final answer. We're going to go ahead and save this last problem for when I see you in class tomorrow. Thank you guys so much for watching, and have a great afternoon.